Quick story. So while Localhost reached out to me for this talk, we were working on doing a lot of migration at where I work. We're working on doing a lot of DB migrations, and I was currently facing a lot of blockers and bugs. And so when they said that I had to pick my topic, I was just in the midst of reconsidering my career choices and wondering why, which is something I do a lot. I'm always like, I could have chosen something easier, but this DevOps is just so hard. And I came across this meme. So yeah, it's just like if you decide to go into this field, become a DevOps, SRE or cloud person, you have to be somebody that just likes technical problems, that just likes to get your hands dirty. And that's why I chose this topic for today. So today we'll be talking about approach to troubleshooting and implementing best practices in DevOps. So my name, as Favor already introduced, is Seriki Ayodele, but you can call me Mia because it's easier for me to hear. And I'm currently contributing to the success at Paystack. So if you have questions as we go, once again, I can't see the chat box, but feel free to interrupt me. So a few things we'll be going over. I'm going to be talking about the technicality of the DevOps practice. And yeah, I'll just be giving like a brief overview. I know we are a crowd of maybe intermediate to senior engineers. So this is just a brief overview of how technical the practice is. Then we will talk about the approach to troubleshooting in DevOps. And yeah, I will be going over some common troubleshooting scenarios that I have faced in my journey. And then we'll be talking about CI/CD as a mentality. And this is just to talk about how we've gone from, doing things very manually to having a mentality shift in how processes now happen in the software development cycle. Then we'll talk about when to figure it out and when to ask questions. I think this is kind of like a good point for like if you're just getting into the field, and even if you've been in the field for a while, it can be like if you're a junior, you can feel like you need to impress and figure things out by yourself, even when you are in the midst of very critical incidents. So yeah, I think it's wise to know when to figure it out and when you should ask questions. And if you're a senior, you might feel like, well, people already think you should know it, so that might be some pressure to you also. Then we'll talk about documentation and knowledge sharing and why this is very important in this career path. So let's begin. So technicality of the DevOps practice. So DevOps as a career path, it encompasses a broad range of technical competencies. So we have infrastructure automation, we have continuous delivery, there is containerization, there is monitoring, security, collaboration, all of that. That's just a high overview to just tell you like how complex it can get, how deep it can get. And we leverage these technical skills to drive innovation, to improve operational efficiency, and to deliver value to our customers through creating enhanced system reliability. And as a DevOps person, an SRE, or a cloud professional, we play a very critical role in bridging the gap between development and operations team. And I think these are like some points to consider to make your life easier when it comes to, navigating how technical it can get. And this is not specific to a tool or to what you might be doing. This is just like generally. So I feel like you need to master the tool that you're troubleshooting. And this ties to my second point because, yeah, master the tools, but foundational knowledge is a pillar. Let's take Kubernetes, for example. And this is one of the best advices I got when I just started out, and it's still something that I do to today. Let's take Kubernetes, for example. You can be a very good Kubernetes developer and just stop there. But there was a time where there was no Kubernetes. We just had virtual machines and Linux and things like that. And there were developers then that had to work with those very manual technical systems. So compare being just a good Kubernetes developer to being a Kubernetes developer that started working with like virtual machines and containers. The difference will just be there. And that's just the thing, like you have to start from foundational knowledge. And there are some of us that maybe are seniors and we don't really care to know about the under the hood workings of like virtual machines, and we know a lot about Kubernetes. It's always a good idea to go back, because you can learn virtual machines and containers and Docker and all of those things and learn under the hood how they work. And then when you try to learn Kubernetes, it will just be a breeze compared to trying to just navigate Kubernetes on its own without having those foundational knowledge. I think things like this, because as you continue to grow in your career journey, you just realize that things just become like instinct. Things just start to piece themselves because of foundational knowledge. So instead of being like, oh, I need to learn this tool, I need to learn Argo CD, and I need to learn Grafana and this, go back to the basics, the very small things that matters that form the foundational knowledge. Then understanding the business and systems. As DevOps engineers, and I'm particularly guilty of this, me, for example, at the time, I would just look forward to getting my own tax, doing my own job, and just leaving it there. It was a very isolated way of working because I did not really understand the business as a whole, where DevOps fits into it. I know like the general, this is your job, this is what you should do, but how DevOps fits into the specific business or the system that I am working on. And this just makes things easier, because sometimes other teams, and this will happen very frequently as being a DevOps person, other teams will come to you with problems from different services from the organization as a whole, and you just knowing like what the service does, and you might feel like, well, that's not a thing for you to know or your part to play, but just understanding this high level, how the system works, how they talk to each other and things like that, it will just make your life easier. I think I'm going to dive into this in a different subtopic. Then let's talk about approach to troubleshooting in DevOps. So troubleshooting is one of those things that is really hard to learn, because the only way you get troubleshooting skills is from troubleshooting things. And even people that are good at troubleshooting, they cannot really tell you like, oh, this is how to get good at troubleshooting, or they cannot really articulate how they go about a thing sometimes, because it just becomes an instinct level type of operation as you progress in your career. So troubleshooting is a part of the overall incident management framework. Like there's other stuff like communicating with your customers, communicating with your organization, your other team members, and very importantly, documenting what you've done. And the purpose of that is so that it can either be permanently implemented or it can be rolled back if what you have done is not the correct behavior. And essence of troubleshooting, well, as you already know, is fixing stuff, is making things work, making things reliable, performing the way they should, making systems stable in the midst of rapid iteration. That's like a lot of changes will come because the ecosystem for software development is so rapidly changing, and troubleshooting is just a necessary skill you should have. I think being able to figure stuff out is greater than being able to just say you are a good maybe Kubernetes developer. If you can figure stuff out, that means you don't really need to know the tool, but you know what to do even with something that you're not familiar with. And it requires a combination of technical expertise, systematic approach, and proactive mindset. And one thing to note is that as you progress in your career, as you continue to learn, most importantly, because you can be progressing and not really be interested in learning new things, the better I get at troubleshooting. And I'm just going to go over the 3 most common troubleshooting scenarios that I subjectively have faced in my career journey. So there is system outages or infrastructure failures, and this is when the whole system is just down or a large part of the infrastructure is failing. And there is build and deploy issues, and this will happen maybe when a developer pushes some code and your pipeline just fails. And then there is application failures, which might be a bit tricky if you are not familiar with the code that the application is being written in. Especially as DevOps guys, I've heard a lot of you don't need to learn how to code to be a DevOps person. I don't know about that, but yeah. So I'm going to touch on each of these points. But let's talk about infrastructure failure and system outages. These are just a bunch of things that I would do. So I will get the steps to reproduce the problem. So if someone reaches out to me and says, oh, I go to the app and I'm not receiving any I'm not getting anything on the screen, I'm not getting any messages, it's just blank or something like that, I will try to do the same thing and see what might be going on. Then check for recent changes. That is like, was a deploy done just before the incident? Because that would probably be maybe you pushed out something that was not supposed to be pushed out, something that was wrong. And then having an overall idea of what the architecture looks like. And I thought about this in my first subtopic about the technicality of DevOps. And this is just knowing what you're working with, what it looks like. I think it makes life so much easier, and it streamlines the troubleshooting process. For example, let's say we have this little architecture. We have a server that's talking to an API, and based on what you are trying to do, the API will talk to SQS or it will talk to a database. And let's say we have a user route and a feed route. If the user is trying to get some information from the database, and if the user comes to you and says, "Oh, I can't get new data on the app or something," once you know, okay, the API talks to the database, it's easy for you to know, okay, this is where the problem is coming from, and you can isolate it. Same, let's say the user is not able to get new feed on their screen, they're not able to refresh the page, you know, okay, this might be an SQS problem. And even maybe the SQS, let's say the SQS is talking to the database, and you're able to see the feed on the screen, but it's just not bringing up new ones, then you know it's probably a problem between the SQS and the database. And this just makes it easier. And imagine not having this information. That means troubleshooting would kind of go a different route, might be a bit difficult. And that might be the case most of the times, because although architecting your infrastructure is best practice, I don't think it is done a lot. So in that case, I would like to break my troubleshooting into smaller parts and just isolate the problem. And that's where logs come in. They always say read the logs. The logs are always telling you something. So for example, let's say I have this code. So if this statement prints and it says first or last name you entered was too short, this is basically telling me where the problem is. It tells me what the problem is exactly, and I can know where to take my troubleshooting from there. I can know the correct steps to take, move forward or backward. But the thing is that logs are not always useful, I've come to realize. For example, let's say we have this other piece of code and it says do some cool stuff, and there is an except statement where we to print LOL if it's not able to print do some cool stuff. Now, this is not very useful because it does not exactly tell us what the problem is. It does not tell us that, oh, you can't print some cool stuff because of something. It just prints LOL. So the logs might not always be useful. So that's when other things come in, like, you know, going deeper in your troubleshooting. And another point on system outages. So because of how critical it can be, there is a huge difference between fixing the system and getting the system back online through whatever means possible. And if you have been on call and you are the person that is the resource to fix a thing, you might just find yourself having to get the system back online instead of fixing the actual problem. And getting the system back online might involve just training a bunch of extra servers to just get it up and running. It's different from actually fixing the system. And a common mistake that I used to make was try to fix the root problem. And sometimes I'll just realize that that was just merely a symptom of the problem. That wasn't even the real thing. And I still have a lot of work to do. So sometimes it's just best to get the system back online through whatever means, increasing the memory, training some servers, and then going back to fix the actual problem. Then let's talk about build and deploy issues. And steps that I kind of take to mitigate them. So I try to run the failing step manually. And to do this, I need to understand what the pipeline is doing. Because the pipeline is a combination of steps that if the pipeline did not exist, you'd have to run them manually anyways. So just taking out the failing step and running it manually isolates the problem. One thing I used to do, which was very terrible, was if my pipeline failed, I would try to, do a little bit of debugging and Googling, make some changes, then I would push again and make the whole pipeline run till it gets to the step that is failing. And if that does not work, I'll go again and wait for the pipeline to run again. So it just makes sense to understand what your code is doing. So you know to run the failing steps manually, isolate the problem, and that involves you just understanding what the pipeline is doing. Then I don't have a slide for application failures, but I mentioned that earlier. So that's just like, yeah, that's going to be difficult if you are not familiar with the code. And like I said before, in those cases, because we are cloud guys, you might just need to bring in a developer that understands what is going on, especially if it is critical. And something else that might help is being able to set up the application. Like if you're just, the person that does a bunch of little stuff the application, you don't really get familiar with it. Learning to set up the application yourself, get it running on your local system might be a huge step to making life easier. Then let's talk about CI/CD as a mentality. So before CI/CD practice became widespread, the software development and deployment processes were often more manual, like I said before. They were slower and they were prone to errors. So we had things like manual integrations. That's when, like, if you are different developers working on your team and you are working on different small parts of a big thing, you have to work on your own part. And then when you try to put it together, because of differences in the code bases or just differences in what they might have used to start up the application, you start to have errors and there's just complications in trying to integrate. And we had infrequent deployments. There was limited visibility where, nobody really knows what you are doing because you are setting it up on your local, using all the tools on your local. So nobody really there's really no standard as to what is going on. So CI/CD is kind of like a shift from what we are normally used to. And it's a mentality that we have to embrace because it's not just something that has just come to make life easier. It also shifts the way that we approach things generally in this field. So embracing continuous improvement, because things will continue to change and like developers will continue to make features and changes. This is just something that you just have to normalize. Just have to normalize not never ending tasks, just being uncomfortable, just the problems that comes with it. And then agility and adaptability. When you are able to familiarize yourself and just normalize people coming to you with new features and things just always happening, it makes you adapt easily. So even when new software comes, you're just able to adapt. Then focusing on delivering value. Because we have streamlined this process, it now makes us able to focus on actually delivering value. Then this is just a small diagram if you're not familiar with what the CI/CD process looks like. So that is, you write your code, build, test, you operate. This is a very popular diagram. I think everyone should have seen it. Then let's talk about knowing when to ask questions and when to figure it out. So this is just something that yeah, like I said, you might struggle with if you're just beginning, and even when you're advancing the career, just knowing when to figure it out and when to just stop debugging and ask for help. And something that can help is cultivating a learning mindset. For example, when I just started out, I would see a bug, something would fail, and I would just take it to the senior engineer to just fix it and just make the bug be gone. But that deprives me of all the learning opportunities I could get. Like if there is a small problem that I have to Google, even though Googling might not give me the solution to that problem, there might be a documentation on that tool, and that means I have to go through the documentation. Or there might be a what's it called now? Slack Overflow chat where I have to read through and learn new things. So just opening up your mind to just know that, okay, you're willing to learn. When you see a problem, it's an opportunity to learn. That really helps. And then consider the impact and the deadline. If it's something critical, of course, you have to ask as soon as you can. You cannot just say, okay, that's not the time for you to want to learn stuff. It's time for you to ask. You have to consider the impact and the deadline. If it's something that is too far away, fine, then it can be a really good learning experience for you. And then knowing when to ask questions and when to figure things out independently comes with experience and judgment. Like I said, it becomes an instinct level type of operation. And also this kind of ties to, having foundational knowledge, because when you just know, you just know. Like sometimes you might not even be able to explain how you just know stuff. It just starts to make sense like a puzzle. And then you would know, you would also have experience and know when to ask questions, because your questions will start to be kind of getting defined. They will start to be smarter and you will just know. Then I have a 5-step approach before you know whether to ask questions. And this is something I do personally. I try to follow the steps. So I do my due diligence. For instance, when I see bugs now, I don't just take them to the senior engineers. I try to think first, what could have caused this? Is this something obvious? And when I used to see error messages, they used to be very abstract. I just did not like them. I mean, so do your due diligence is making sure you actually read and understand the error message. If it is not something generic, because it's kind of somehow when the error message is basically telling you change this thing, or the string you're using is too long or something, and you're taking it to somebody else and they're just telling you, it says in the error message that the string is too long. Like they're telling you what's already obvious. It kind of shows that you're not really putting in the work to get better. So do your due diligence, then spend some time doing some clear-headed debugging. And I said specifically clear-headed because the debugging environment, when you're troubleshooting, is not an ideal environment for learning, because you might be tense, having some anxiety, especially if there is a deadline. So it's best to just calm down, because there's nothing that your anxiety will do to fix your bugs. So do some clear-headed debugging. That's when, Googling comes to play. If it's something, and sometimes you might just copy some bugs. And one thing that is of comfort is that the problems you've had as a DevOps or cloud person, somebody else has probably already had that kind of problem, reported it somewhere on the internet, and somebody has probably come up with a solution. So sometimes when you just take the error and Google it, you will just come up with your solution. So, but if you are just anxious, you might even miss it and just be going into O's and O's. Then check the documentation. If you're debugging a tool, the people that wrote and created the tools have already put out instructions for how it works. It's like when you buy an appliance in the house, you read the manual on how it works. You don't just try to figure it out with your common sense. So it's the same thing as checking documentation. Documentations help you to see how it functions basically. And sometimes in those documentations, they have a section for frequently asked questions, which is it could probably just be the problem that you're facing. And then check the source code. This is something I kind of struggled with because because I did not write the source code and I'm not even a coding person. So it's something I kind of struggle with. But as you go on, as you practice checking the source code, there are just things that even I cannot really explain now. There are just things that just make sense there, that just helps you to fix the problem most of the time. And if you have done all of this, you've gone through all this journey, then of course you can ask your question, because if the engineer that you go to meet decides to maybe up on a call with you to debug the problem, they might be doing the same things you've done, and you can just relate because it's something you've done. You can help them out instead of just leaving the burden to them. Because when you go with the DevOps person, when they come with you, when you go with another person with your problem, that means they have to also, be in a state of mind to start troubleshooting, especially if it's something they have no idea about. They have to start troubleshooting from scratch. So you already taking all the steps that it takes, even when it's something not related to DevOps, maybe it's something else. You taking all the steps, it gives you the learning experience, and it just makes life easy, and it's just best practice. Then let's talk about documentation and knowledge sharing. This is so important. The very basic instance I can give of how important this is: if you just join the company that does not have documentation on how things work, you know how difficult it is to navigate things by just asking questions and trying to figure things out. Oh, I say I spelled documentation wrong. You see how difficult it is to just navigate things. So there are just some points of like why it is important: consistency and standardization. it just makes life easier. If you've done something, somebody else can pick that document up and do the same thing instead of having to go through all those and waste time and things like that. And it makes sure that if you do something a certain way, let's say we implement something in Terraform in particular way and you have documentation for it, somebody else will not come and implement it a slightly different way. And then when a third person comes, it's like kind of confusing. So it promotes consistency and standardization. It is very much best practice to just have documents. Then if you can't explain it, you probably don't understand it. So one advice I was giving is document everything you're learning. And that is something I try to do, even though I don't consider myself much of a writer. I try to document everything. So if I have fixed a problem, I will document it. If it's something that I have done all the steps to troubleshooting, and I've asked somebody and they don't really know, it's difficult, that's definitely something to document because it will definitely come up again somehow, some way. And it would be so useful for someone to just have a document instead of having to come to you and you probably don't even remember it sometimes. So being able to document it and explain that and share that knowledge helps you to solidify the knowledge yourself. And if you cannot explain it, you probably don't understand it. And that's like a good way to always check yourself. Like you might fix something or do something and feel like, oh, I know this thing, I'm good. But when it comes to explaining it to another person, you might have a bit of struggling points. And being able to face those struggling points and overcome them, it just makes you better all around. Then knowledge transfer and collaboration. So documentation and knowledge sharing, like I've said, like in the case of onboarding new engineers, transferring that knowledge, it just makes it way easier. It makes it easier for them to collaborate with you. It reduces the amount of questions that you'll be asked. And it's just, like I said, best practice overall. And yeah, I think that's the end. Thank you. Questions? I'll stop sharing my screen now.
Hi, my name is Du.
Hi.
I just want to first of all say thank you very much for the presentation. I think it was very good. Just to start off with the questions, I wanted to ask, what would you recommend? Because you said something about if there's an issue, if there's a downtime, for instance, we give out all the steps, and which is pretty amazing. So I wanted to say, how do we define the moment when we try to solve the problem ourselves, and when we hand it over to maybe a larger team or a senior engineer? At what point do we know, oh, this is getting out of hand, or we should pull in people to come and help us or something like, or we should try to fix it and take it as a learning point or things like that? At what point do we make that decision?
Okay, well, like I said, I think you will just know because depends on the deadline and how critical it is. I mean, if your app is failing and you know nothing about it, you will not say, okay, let me learn about this now because you're losing money, you're losing time, you're losing a lot of things. That's definitely time to bring in somebody. So I think you will just know when it's time to bring in someone. But if the deadline, if you're working on a casual kind of task and the deadline is far, maybe it's your sprint work and first day of your sprint you realize, oh, I don't really know this too. That's time for you to learn and take your time and do those things. Hope that makes sense.
All right, thank you very much.
I'm just checking the comments, but if anyone has any questions, you can just pop them up.
Hello, good evening. Toluwalokwe here. So I want to ask a question. You earlier when I joined, you were talking about fundamentals, knowing the basics properly, and at the end of the day, everything sort of joins together. Yeah, I agree with you in some other areas I've experienced, so I know that's very important. So at this point now, what are the real basics? I know you mentioned Linux, you mentioned virtual machines, but I'm like those two things for something as broad as DevOps, like it looks too small for that. So I don't know if you can lay emphasis on what is really proper for the foundation or basic level, so that I can ground myself properly in that area as I'm just starting out.
Yeah, I think one thing to point out is the under the hood of how those things work. Fine, virtual machines are like a smaller part of the big picture, but how does it work? How did it come together? How did they even start out that? It's like contributing to open source, let's say contributing to Kubernetes. You contribute to the small pieces that make up the whole thing, and that gives you a very, very deep knowledge of how every small piece comes together. So when I say virtual machines and Linux, it's like under the very basic stuff. And it might seem like things that not very important, like let's get to the main thing. It's like me at a point when I was learning Python and I thought I was doing pretty good. I had this friend, and one day we were just having a casual conversation, and then he asked me, do you know like how he was talking about garbage collection in Python? I was like, I've never heard of anything like that in my life. I like it's just like things that are under the hood that people don't really care about, or they don't really take as something serious. So it's like learning those things, understanding is like when you have something and wanting to understand how this thing works, like databases, how are the engines created, what are the internals, all those things. When you can understand it, the bigger things come and it's just a breeze, because the how do they call it? It's like growing a tree. The root is deeper than what comes up. So it will just start to compound all of that foundational knowledge. So like I said, the internals of how virtual machines work and containers and things like that. And you want to learn Kubernetes, it's just a breeze. Like it's just all familiar to you, even though you've not used it before. Hope that makes sense.
Yeah, thank you so much. I think that really makes sense, because tools change is the what's it called, concepts that still remain the same over time.
Yeah, exactly.
Thank you so much.
And sorry, Justice, before you ask the question, just to say, because I was watching this DevOps conversation where the DevOps guy engineer, he was talking about how developers of nowadays are not very in-depth in their knowledge, because there are all these new tools that have just come and made our lives easier. There's Kubernetes, so you don't have to do the manual things that you do with virtual machines and stuff like that, and people just know surface level knowledge. But and how they say the ecosystem for jobs now is choked up. Imagine standing out by being the person that knows the small things, that knows how things work in depth. So that's just the essence of knowing your fundamentals, really. It's like ABC that makes you know how to join up words. ABC is very easy, but if you don't know it, your English will not really make sense. Yeah, Justice, you had the question. I have your answer.
Okay, all right. So I'm Justice Asare Usu from Ghana, and I just wanted to ask someone who is starting out as a DevOps engineer, which cloud provider should I start out with?
Interesting question. Just starting out. Well, if you've gotten to the point where you're starting to learn about cloud providers, I'll say you can pick up any one, to be honest. I'm only familiar with two, AWS and GCP, but I'll say ideally just pick the one that's most popular with companies, maybe AWS, because that gives you ginger. Because when you go to maybe a forum, you see a lot of people talking about AWS, compared to if you're maybe you're learning GCP and people are talking about AWS, it makes you feel like not very interested. But before then, there are a bunch of things you should learn before getting to the point where you learn about cloud providers. But ideally, I would subjectively say AWS. Yeah, opinions could be different. Right. Solani.
Okay, thank you very much. I have two questions. The first one is when it comes to as DevOps engineer now, like I said at the beginning, when Chico was asking us to see how our week went. So I wanted to know, as a DevOps engineer, you integrate or you basically use the DevOps practices into the SDLC cycle. So have you done DevOps on mobile application? Because there's web, there's mobile, and for now, me, I was getting to know that some of the tools I use are different, some are the same. So I don't know if you have anything to say on that.
some of the tools are different, some are the same. Can you talk more about some of the tools that are different, some of them are the same?
Okay. When it comes to I was just researching not quite long before this meeting. When it comes to like web applications, now you have cloud providers like AWS, Azure, and the likes. When it comes to mobile, I was for my research, I was seeing things like I think Google Console and the likes. So I think even though things like CI/CD tools like Jenkins still remain, Git and GitHub version control systems still remain, but they're like different tools when it comes to, there are some tools that are different when it comes to web and mobile. So and mobile applications are becoming widely used than web, obviously. So
Yeah.
if you know what to say, if you can do that.
Honestly, I think that's very subjective to what your spec is for the mobile or the web application. The tools that I use are very subjective. It depends on a bunch of things like how easy it is to learn the tool, or how easy it is for other people to collaborate and use the tool. So depending whether it is web or mobile, those tools don't, it depends on the application itself, the kind of application you are working with, or the web server you are working with. They will match the type of DevOps tools that you're using. So for DevOps, so they don't really choose like, because you're using mobile, use this tool. I don't know if that makes sense. It depends mostly on the application. What do you want for the application? What is your level of expertise? What do you want for the application? How much do you want it to scale? Then that determines the tools that you will use. For example, if it is a small scale mobile app or web application, you probably just stick with using Docker first instead of going to use Kubernetes, because that's a lot of money for a small application that you don't want to scale or do all those big things that Kubernetes is meant for. I don't know if that answers your question.
Not really. But okay, like for instance now, when you deploy in web application, you can deploy, let's say for deploy with Docker, you can be able to view what you deployed on the web browser, obviously. But when it comes to app, the app has to be in an app store, and like you have a mobile app where you can check it. So I don't know how to do that. I don't know.
Maybe I can help answer that question. When it comes to deploying mobile applications, it depends on how the mobile application was built, right? If it was built with Iconic or non-native React Native, sorry, you can actually be involved in the end-to-end process of CI/CD, of building the application, that's packaging the application, and generating an APK file for Android or the app for iOS. So basically, before your app goes to the Apple App Store or Play Store, you can actually generate the app itself where you can share to people to test, right? So devs can still be involved in the end-to-end process of mobile development without having to interact with the Play Store until the application is ready. Does that make sense?
Yeah, that makes sense. Thank you very much.
Okay.
Only you had the hands up.
Yeah, thank you. Thanks so much. So the last time you partly answered my question that was going under the hood and knowing what's going on. Yeah, so I still have another like questions. It's just to define the time what makes the basics really means. So I have a friend, he does SRE, site reliability. I think they are kind of related to DevOps. I don't still know the difference properly yet, but that's not the bone of contention now. I think the thing now is that he advised me that, man, I should not just jump into DevOps, all these Ansible, Prometheus, all these tools directly. He said I should go through IT support first. I mean, IT support, stating out some roles, like things that we have me learning, networking, operating systems administration, and some little bit of cyber security. Like if I go through that route for like maybe a year plus or so, I will get the foundations properly. Then I can now start shooting for DevOps. And now I'm still trying to even learn for the IT support. I'm like, I don't know. I don't know when I'm going to finish this. Let alone now starting DevOps. Like, I'm like, this foundation is too, like, this fundamental looks too bulky. Let alone starting the routine. I'm like, I just want to start the real thing. Just give me the real thing. But it's like, hey, be patient. This is the true way. This is how the masters get there, not the, half big guys. So I'm trying to, follow that. But at the same time, I'm like, it's getting too long. So I'm just putting this out there, here so that I can clearly, define, okay, is it just saying this based on his own experience, or is this actually the real best way to follow to be very, very good eventually?
Well, so I think that's great advice. That makes perfect sense because DevOps itself is development and operations. It's a combination of everything. That's why it's so technical. It involves IT, involves all of those things. And me personally, because I did not go through, ideally, looking back, I would have probably been a back-end engineer first before I came here, but I just went straight into SRE. I started with SRE. And the difference, well, yeah, like you said, this is not. I started with SRE. I basically use the same tools, same processes as a DevOps engineer. So when I say foundations, I mean it's still DevOps is still a combination of all of those things. In fact, best thing to do would be to go through a what's it called now? Software engineering kind of phase where you're just learning about software engineering. Forget about DevOps first, because DevOps is like I don't know what to call it, but like go through the software engineering phase first, learn about operating systems, learn about how those things work under the hood before you even start. Because DevOps is, when I just joined Paystack, my manager was saying like it's mostly like seniors and principals they were hiring because DevOps is like something is not. It's not something for like any level lower because it's just so complex like that. And well, at the pace that they were working, they just and if you see now, their companies are really hiring like junior DevOps engineers because it's kind of a myth to say you're a junior DevOps engineer. You have to maybe have been a backend engineer, but it is possible to directly be a DevOps engineer. So when I say basics, it's like your friend is right, learning about the operating systems. I think there is a popular roadmap, roadmap.sh for DevOps. That's what I started with, and I was following it step by step. It breaks down like the fundamentals and the basics. And if you take a software development course, they break down the basics too. They talk about all of those things and all the things you need to learn. They might even go into you might need to learn like there's so many. Like there's one course that teaches you just zeros and ones and things like that. Those basics like that. Yes, they talk about like addressing networking. Networking when it starts with zeros and ones, bits, wires, things like that. So all those kind of basics to just compound to make sense in the future. And it's okay for you to be confusing at first. You are supposed to, if you are not confused, safe. I don't know what you're doing. You will be confused at first, and it might seem like a lot at first, but you just realize that time will just fly and you will just be good. Like it will just be good. Does that
Okay,
help?
thank you. Yeah, it really helps. I'll be patient.
Yeah, be a lot of patience because the journey is long. So a lot of patience. Oh,
Thank
you have
you.
your hands up.
Sorry, I think it was from before. Sorry.
Okay. I don't see questions from the planning.
Yes, okay. Earlier you talked about when we talk about CI/CD pipeline, this with integrating different tools together. When you're talking about
Yeah.
troubleshooting, like to better understand or better be able to troubleshoot, you should isolate different tools and run them to see if you are getting the expected results. Be able to troubleshoot. So I want to expatiate on that particular thing.
Okay. So, for example, let's say, for instance, your pipeline has a test step, it has a build step, and it has a deploy step. if you are having problems with the deploy, I gave an example that in my case, let's say I had a problem with the build step. I will go and maybe modify something, maybe the container name or something like that, and then I would make it run from the test. And let's say test is taking 30 minutes to run. It will run from the test. I will wait till it gets to the build step before I see my problem, if it has been fixed or if it just throws a different bug. So isolating in that case is just running those. If you are building with Docker, running the Docker commands locally on that application instead of having to make the change, do a push and a commit to your repository again for the workflow to run. Instead, run the Docker commands locally, isolate the problem. Try to, if you are using Terraform, try to do a dry apply locally to see if it works, because that just makes it faster. And especially in an organization where somebody has to approve before you trigger the workflow, and let's say it throws a different error, you're not going to do the same. Somebody has to approve again. So best practice is being able to understand the tools and being able to run those commands by yourself locally. Then you just know that when you're pushing what is accurate, and you're not stressing the engineers that are reviewing for you. Does that help?
Okay, you mean yes, I think you mean manually instead of doing it automatically, right?
Yes. So yeah,
Based on
doing it manually. Yeah.
yeah, thank you.
Okay. Any more questions? I think that's all for the questions.